everybody. Welcome to the Creature Crossing podcast. Today we have a super special episode. I'm joined by Amelia Zietlow. How are you today, Amelia?
Doing good.
Who are you? We're a herp podcast, which I mean, to be fair, like mosasaurs are kind of part of that, but a lot of people may not know this exactly. So, could you give yourself a little introduction?
Sure. So I am a paleontologist. I'm currently working as the museum specialist at the History Museum at the Castle in Appleton, Wisconsin. This work was part of my dissertation research while I was a PhD student at the American Museum of Natural History's Richard Gilder Graduate School in New York City.
Awesome. So, what work are we talking about today? Which I'm super
Sure.
excited to talk about, by the way.
Sure. So last week I published a new species of mosasaur, Tylosaurus Rex. Mosasaurs are a group of extinct herps from the late Cretaceous, so from the very end of the age of dinosaurs. They're literally lizards, so unlike dinosaurs and other marine reptiles, they're actually not this weird extinct group that we don't have represented anywhere today. They are literally just lizards. Their closest living relatives are monitor lizards and snakes.
Awesome. Which, by the way, some of my favorite lizards. I mentioned to you a little just before we started recording, we did another like paleo episode. It was about mosasaurs. So I do not feel bad about having two mosasaur episodes in the slightest. Actually, I think it's awesome. Now, before we get into it a little more, I do have your Instagram pulled up here, and I see that it says metal and mosasaurs. What is
Yeah.
the metal part referring to?
Rock and metal music.
Okay, so that's what I was hoping. What do you listen to? Because I had Ron St. Pierre, who's a reptile keeper on, and he's like buddies with all the guys from Slayer and stuff. So at the end, I was like really grilling him about a bunch of stuff.
I listen to a variety of things. Like it just kind of depends on the day. I don't know if you saw this. We also made a playlist to go with the paper that does include some metal. It had to be kind of Western because it's from Texas, but
Yeah.
we did a mix of like particularly violent metal, anything that listed lizards or bones or whatever. I tried to include that. But yeah, really a variety of things.
Nice, awesome. I always appreciate somebody who has a good taste in music. So that's awesome as well. So can you now? My mind immediately was going to be like when I looked at all the headlines and stuff, and I saw all the videos coming out about this, and all the my immediate first question was going to be like, okay, how big is this thing? But I'm kind of getting to the point where I kind of hate that question.
Yeah.
So instead, can you talk about? So this is a new species of Tylosaurus, not really new, but just newly described, right? Like the fossil wasn't recently found. Am I correct?
Right. Yeah. So something that might be surprising to people is that not all fossil discoveries of new species actually come from digging up a new fossil in the ground. Sometimes it just takes a fresh set of eyes on old collections. This study includes over a dozen specimens, and of those, the majority of them were collected at least a decade ago.
Okay, yeah, so that's what I thought. So, but a newly named species. Can you compare it to like the big hitters that everybody's aware of? So, like the other Tylosaurs and like Mosasaur, Hoffmanni, things like
Yeah.
that.
Yeah. So it's all things considered, it's relatively similar to Tylosaurus proriger. So for people who already know about Tylosaurus, that's probably the one that you think about. Although I say that like the rest of them are super different. They're not, and that's part of the reason they're an interesting group for me at least, is that they're very anatomically conservative. So like they're around for about 20 million years, and they don't change a whole lot at all. Like a Tylosaurus from 93 million years ago looks very similar to a Tylosaurus from 70 something million years ago. So, compared to mosasaurs, they're very distinct anatomically. So, mosasaurs as a group are actually a lot more diverse than a lot of folks typically give them credit for. There are four distinct clades of mosasaur, and the more of these things we find, the more evidence suggests that they actually diversified before they had flippers and giant size. So the group independently evolved flippers at least 3 times, possibly more. And they all converged upon the giant sea monster body type. So Mosasaurus, realistically, it's a little bit later. occurring than Tylosaurus, you could argue that Mosasaurus was copying Tylosaurus's homework. So both of them are really large. Both of them were macropredatory, so eating things larger than their heads. Beyond that, in terms of like actual size, it's hard to compare them super directly. Because they are distinct groups of animals, their proportions aren't one to one. So Mosasaurus skulls are proportionally larger relative to their body than they are in Tylosaurus. And we don't have as many complete Mosasaurus skeletons. So like something we did in this study as well was estimate body lengths for like a dozen of these, a dozen Tylosaurus, give or take. And we were able to do that because there's several specimens that are known from complete skeletons. So we were able to kind of backtrack and fact check these proportions to see which ones actually held up against the real whole skeletons. With Mosasaurus, we can't really do that, especially not Mosasaurus hoffmanni, which is like the Mosasaurus. It's mostly known from isolated skull and limb material, some isolated skeletons, but nothing like super complete to the degree where I would have any confidence like estimating their body length. But if I had to guess, I would guess that they're neck and neck and roughly the same size. So topping out between 40 and 50 feet long.
Okay, so like for a comparison today, Nile crocodiles and saltwater crocodiles, they're incredibly similar in body proportions.
Yeah, like from the outside, most people probably wouldn't be able to tell them apart, frankly.
Yeah.
Even though they're like incredibly disparate. I would argue they're even more similar to like crocodiles and alligators broadly. Like they
Okay.
diverged many millions of years ago. But they just, to the average person, they look almost identical. And I mean, the interesting thing with mosasaurs is again that body plan of being huge and having flippers is something that evolved independently in multiple lineages of mosasaur. So they're not like separate groups of lizards; they're all one group. They just did this transition multiple times.
Yeah. Okay. So, man, I like every time, like I told you, we had another mosasaur episode. One of the things that I really find cool about mosasaurs, I think there's not a lot of animals living or extinct where you can look at them and when you see headlines calling them all these crazy words that get people to click and want get people interested, there's not a lot of them that I think deserve it. And I don't mean deserve it in a negative way. I mean it as in
Right.
I don't like those words because they kind of portray a lot of these animals in a way that maybe they shouldn't be, in my opinion. But these
Right.
things were crazy. Like,
Oh
you know
yeah.
what
No, like
I
every couple of years, if not every single year, there's a marine reptile discovered, and the headlines are always it's the T.rex of the sea. And we're like, you know
yeah.
what? We're gonna make it for real this time, and it's actually gonna deserve it in ways that sometimes the other ones don't quite. Um,
Yeah, that was I think it's safe to say that was a bold choice and I'm all for it because that is badass. And I'm all about things that are badass. And like me, I try not to be like my co-host calls me a size queen. I try not to be a size queen, but like I mean, if you were to ask me like, "Oh, what's your favorite mosasaur?" It's like, "Well, it's probably Hoffmanni because like it's the biggest supposedly or whatever." You know what I mean? As somebody who's never really looked into research that much about mosasaurs, this one's pretty cool though. It might be kind of kicking out, some of the little guys that Jared Cook introduced me to are up there too. Like some of the little cute ones that maybe I could get away with keeping in a little enclosure at home would be awesome. But Tylosaurus Rex is I mean, it's you guys aren't trying to hide this animal. You know what I
no.
mean? And I think that's very awesome. How many T-Rexes does that make? Like three,
Oh, there's
four?
more than that. There's over a
Yeah,
dozen, and
there's
that's
over a
not even.
dozen.
Oh
Wow.
yeah, there's a lot. I've been saying dozen a lot, but like that's just a good number for a lot of these things.
Yeah,
No, there's many T-rex, quote unquote,
yeah.
animals. And a lot of them are bugs, but there's a couple not. I feel like there's at least one or two mammals.
I think there's
Um,
a dinosaur in there somewhere named
I'm not
T-Rex.
possibly. I don't know. And then there's also that's not even counting. I imagine that botanists have done it as well. Like I know of at least one plant that is also abbreviated as T-rex. So
That is pretty
it's
cool.
we're not the first. We won't be the last, but
Yeah,
we thought it was fitting in this case in particular.
yeah. I think so too. As somebody who doesn't have a dog in this fight, I think so too. Now, one thing I noticed very immediately was you guys. I don't know who spoke to who, but you guys did a thing with the game Path of Titans by Alderon Games, and they added a new subspecies in that game. It's a game I play. And so seeing that, I was like, okay, like this is pretty cool. Like you guys are, it almost honestly, like, not to make it about myself, it kind of felt like you guys were, doing this for me. So, but I did, jokes aside, I thought that was very cool. Was that, like, how was the process of like, so when they built this animal, I assume they were working alongside you guys pretty closely. What did that process look like?
Yes. So at some point last year, I think it was last year, I don't remember. We've been working on this project broadly for I've only been working on it for 5 years. So my co-authors have been working on it for 10, 15 years. So it's a big project with a lot of people involved. But Path of Titans reached out, I want to say last year when they were modeling the Tylosaurus for the game. So they were asking me to consult on it and just kind of help kind of guide that process. Um, and at the time we were, I think, nearing the end of getting ready to submit the paper. So I floated to them like, hey, what do you think about releasing a new species in the game with a new species like being published? And they were like super into the idea and super excited about it because they've never done that before.
No.
So I helped them with the regular Tylosaurus models as well. The original game plan was that the whole Tylosaurus model and the paper would come out together. But this paper was a monster, so it took forever to get through review and editing and all of that. Not because like we had trouble, but because we had at least one reviewer who I think literally read every word, which is great. But that like includes like all of the appendices and all of the extra data, and like it's a really long paper. So it took a lot of time for them to go through it. It took then a lot of time for us to go through and make all of our edits. And then for the editor to go through and check all the formatting. And so this whole process is almost a year long, which is a long time. I mean, it's not that bad as far as academic publishing timelines go, but like it kind of dragged on longer than we thought it would. So Tylosaurus in the game came out a couple months ago, and then I let them know when this paper was about to drop, and they were able to patch in the Rex model specifically.
Okay. And when they released their like announcement, they also released an interview with you. Did you guys record that back then, or did you record it after the fact?
We recorded it after the fact, so I want to say that was a couple days before the paper came out. It was either a couple days or the week before, I don't remember, but that was
Okay.
recently. Like once we had a day and they were working on the patches and stuff.
Awesome. Okay, that's really cool.
Mhm.
The did when it came to them modeling, like one thing I'm curious about this, and it'll probably be the last thing I ask about this specifically, but when they were working on the model for this new subspecies specifically that they added to the game based on Tylosaurus Rex, was there a lot of back and forth between you guys?
Not like a super much amount because like they already had the pro rigger model, which I helped them kind of fine tune. And like Rex is essentially if you took a pro rigger and just beefed it up, made it bigger, made it badder, made it like more jowly. So it wasn't too bad. Like it was just a couple notes, and like they're already really good. They already have a sense of anatomy and of the animals in general. I had given them a bunch of references a couple months ago, like when we were going through the initial consulting part. So there was some, but like it was mostly pretty simple stuff because like again it's basically pro rigor but beefed up.
Okay. Yeah. One of the things that really struck me as notable um when all the paleo art started coming out and a lot of the different like photo comparisons between this new Tylosaurus and other species, I find that whenever I see like let's say a like comparison of like a theropod dinosaur to like a human, I always feel like I'm kind of like underwhelmed 90% of the time. Like I'm always
Mhm.
like, oh well, like I grew up with movies and they're always bigger, right?
Yeah.
And realistically, if I were to see those animals in real life, I'd be like, oh shit, like this is serious. But I do not get that feeling with the models that people are like posting and presenting of the size comparisons between this animal and Tyrannosaurus Rex or like a human being or like vehicles and stuff. Like this thing is really really big.
Yeah.
Not to keep hammering that specific point home, but it's longer than Tyrannosaurus Rex by a few feet, right?
Yep.
And do you guys know like estimates on weight if it was heavier? I would assume maybe because it's in water. it would be heavier.
Probably, but that's like a subset. We didn't do those estimates, and that's a
Okay.
subset of like math that I have not learned. I'm not
Yeah.
experienced with, to the point where like I'm not even going to throw out a number because I have no
Yeah, for
idea what
sure.
I'm doing. I
Are
would
you
just be
guys
like,
I assume, and this is obviously not my field, but I am anticipating, or I was assume that you guys are anticipating a lot of that sort of info from other sources coming through over the next few months to years,
I
kind
really
of
hope so.
adding on
Yeah.
to this.
I
I would
really
love
hope
to hear
so.
about it.
Because the other like big part of the paper is I published the entirety of my measurement data. So like in the 5 years of doing a PhD, I traveled to 22 museums, measured 342 mosasaurs, and like uploaded all of that as an Excel sheet so that anyone can download it and do their own work with it. So that all that data is now there for someone who is more skilled in statistics and that kind of mass estimating stuff. They can take that and do their own research using our data. So part of the one of the goals of this paper was to make this animal and more broadly mosasaurs like more accessible to everybody. I had a lot of trouble like when I was first starting out learning their anatomy and learning about them because neither of my advisors were mosasaur people. So my undergraduate advisor worked on tyrannosaurs. My PhD advisor worked on mammals. So I kind of had to figure a lot of this stuff out on my own. And what I was running into is like I would be seeing lumps and bumps and holes on bones that weren't labeled in figures in the existing literature, and I would have no idea like what I was looking at. So for this paper, we wanted to figure every bone in every view with everything labeled that we possibly could think of. References to which way is left, right, up, down, because sometimes that's confusing from a picture. Um, and yeah, and then also a part of that again was uploading that data set so that it's available for other people to use. Because not everybody has like the resources that I did while I was a PhD student at the AMNH. We got a yearly like research budget that we could use to go travel, to go to museums and stuff like that. Not everyone has that. So getting this data out there makes the animals broadly more accessible to more people.
Yeah, which I think is so. I think it's so fantastic seeing that, and then whether the paper is about this or tyrannosaurs or whatever other animal, new animal, maybe like seeing what happens over the course of years or down the line decades is so cool. Just to
Mhm.
see how collaborative everything, every aspect of paleontology and other sciences too, of course, are is always something that I look at, and every time I notice it, I'm surprised and I'm like, this is awesome. It's such a cool thing to see, and what you guys are doing is no different. One thing I wanted to ask is when you were going through these collections, researching the materials at them, did you find, and maybe you can't even talk about this, I have no idea how it works. Did you find other species that you think are like this is also weird, but it's not Tylosaurus Rex?
Yeah,
Yeah.
in
Okay. Of
short,
course.
yeah.
Yeah.
There's
Okay. I
the
think.
there's mosasaurs everywhere with those with eyes to see or however the saying goes. Like,
Yeah.
and that's kind of that's the other takeaway of this paper. I think like tylosaurs forever have been kind of written off as the boring ones. So like I said earlier, they exist for like 20 some million years and they just change very little. And it makes that makes it really difficult to suss out species level differences between them because they're really subtle and you have to see dozens of them to start to pick up on those patterns. The other thing making it even worse is that a lot of them were collected during the Bone Wars, and those guys weren't super into like writing down where they found everything. So we don't always have the contextual data, where it was found, what time it lived in, and that kind of information. Which is not, in my opinion, that's not the most important thing to have when you're naming a new species. Like, it doesn't matter when or where it lived. Like, the anatomy is what matters when you're identifying things. But it's still helpful to put together a picture of what you're seeing. Um, so yeah, the more I saw of these things, the more I compared them to each other and also to modern lizards, the more things weren't adding up the way that they've been, you know,
Yeah.
for the
Did you,
past 100 years.
did you mostly compare them to varanids?
Mostly. Mm-hmm. And
Yeah.
that was primarily not because like I think that they're their closest relatives. That does tend to be the side of the debate that I fall on. So it's not clear currently where exactly mosasaurs go within modern lizards. Um, I tend to lean that they're somewhere in Anglomorpha or Anglomorpha adjacent, but other folks believe that they're closer to snakes or possibly somewhere else entirely. Um, But regardless of where they go, the skulls of early mosasaurs and even the derived mosasaurs are incredibly similar to varanid skulls. And that's in part probably because they're both macropredatory, they're both preying on large items. So that makes them really good for comparing like what changes we expect to see in animals with similar builds, with similar ecologies, how they change ontogenetically, how they might differ between males and females, et cetera, et cetera.
Yeah. So I have a random question
Mhm.
that is kind of just out of the blue, but so is the consensus right now that mosasaurs were all live bearers, no eggs whatsoever?
Yes. Yep.
Okay. I
So
remember seeing something about like some egg being found somewhere and they thought like maybe it's a marine reptile, but I kind of like just like wrote it off and I was like, maybe I should have like read that. And now I can't find it
no,
anywhere.
no, I don't agree with that result of that paper. To put it kindly, there's no way, basically, like physiologically, that these things could have laid eggs. They, their arms and legs are made of rubber. Their
Mhm.
pelvis is not even like attached to their spine. It's just kind of floating like a whale's. So they can't crawl up on land. Like it's physically impossible. They can't even do like some sea snakes will lay eggs like in underwater caves, but like they go up into the air because reptile eggs have to breathe air. They're not like fish eggs or frog eggs with that kind of jelly coating that helps them respirate underwater. They don't have that. That was an innovation of our ancestors, of reptilian ancestors, to leave water behind. And we gave up being able to lay underwater eggs in doing that. And then on top of that, there are several fossils of, I don't know about several, there's at least one fossils of really early diverging mosasauroids, so things that still even had legs that have little embryos inside. So we have several lines of evidence to suggest that all of these things were giving live birth.
Do you personally think that those mosasauroids, like this is also kind of random, should just be considered like in the broad scene, like they are already mosasaurs? Like, where do you personally kind of draw that line?
It's a hard line to draw, and it's been debated for decades
Yeah.
because, like I kind of mentioned earlier, the mosasaur body plan evolves multiple times. So I would argue that if you want to call one group of animals mosasaurs, I would draw that at mosasauroids, so like Agialosaurs and those things, which still kind of look like little monitor lizards with legs and stuff. That's where I would draw the line. But it's also like it's arbitrary. That's just kind of an informal term for it. But the problem is you have these little leggy things that are definitely plioplatycarpians. You have these little leggy things that are mosasaurians. And then by definition, because those guys aren't each other's closest relatives, we can assume that Tylosaurs and Halosaurs would have also gone through that transition. So there's no way to call all of the things with flippers mosasaurs and exclude the little leggy things. So that's what I would do. But that's, again, it's a matter of like classification, which in my opinion is a little arbitrary most of the time.
Yeah, yeah, of course. Which I just asked because then I mean, if I'm gonna keep any in my house, it'd be one of those little leggy guys. So
Yeah.
if I want to say I have a mosasaur at home, it's got to be one of the little leggy ones. So, as somebody who, once again, has no dog in this fight, I agree.
Yeah.
Even though it's arbitrary, as are so many other things in life. I've actually been struggling with that recently, where I'm always like, oh God, everything's arbitrary. Like everything is boxes, everything is lines, everything is nothing matters except mosasaurs, right?
Yeah.
Um, do you so did you what like why mosasaurs? What made you get into like specifically mosasaurs?
So it was a couple of things. I mean, I decided to work on them all the way back when I was an undergraduate, and essentially it was that there there are lots of them, and I was interested in variation. And if you're interested in variation, the more the merrier. You want to study something that actually has a good sample size. So there's literally thousands of them in North America alone, and then there's many more in institutions in other places around the world. So they have a really good sample size that makes them great for studying variation. They're often well preserved. Like most of them are really beautiful as fossils. Some of them are kind of crunchy and ugly, but like most of them are very nice, which makes things easier. They were accessible to me as an undergraduate. I went to college in Kenosha, Wisconsin, which is about an hour-ish north of Chicago. So the Field Museum had a collection of them. So that meant like I just had to drive an hour, and I could, as an undergraduate, actually work on real fossils for my thesis, which was great. Um, On top of that, they're also like the fact that they are just lizards and they have close living relatives, that made them easier to study. And it opened up more opportunities for comparative study, for big picture evolutionary kinds of studies, because they can be directly compared to their living relatives. And lizards are really well understood in literature in general. Like their anatomy is really well studied and figured. Their embryology and development is super well understood, relative to many other groups of animals. As an undergrad, I also had some experience in doing research in a gecko lab at Marquette University, and I was like cutting open cutting open the gecko eggs and taking out the embryos and like cleaning them up, photographing them, and doing experiments and stuff. So that already was kind of interesting me, like evolution and development and how they're linked in lizards specifically. And then obviously, like I'd be lying if I didn't say it wasn't because they're cool, because that's part of it as well. And like for my job, like as a science communicator in general, or like as a scientist who communicates also about my work, like it makes my job a lot easier if the animals I'm talking about are already kind of interesting. So I've been able to get people like really excited about them, and that's great for especially like general audience type situations where you might need to do a little bit of work to get people to care about evolution and why it matters, or fossils and why they matter. It's a lot easier to do if you show them a picture of a lizard and tell them it's 50 feet long with an extra set of teeth. Like that gets people pretty excited pretty quickly.
And if you call it T.rex,
yeah,
that'll help too.
that certainly has helped considering the amount of interviews we've had.
It's like one of the first times that I can remember seeing like the comparisons to T.rex and it being like legit. You know what I mean? Like it's so overused, but like in this case, like, yeah, actually, yeah.
That was the gamble. And like we acknowledge that it's a little bit silly. And we acknowledge it in the paper as well, because there's a guy that was working for the Perot Museum in Dallas, where a lot of these things are. In the 60s, he wrote a letter to a friend, like suggesting that these Texas Tylosaurs might be something new. And they're all huge. So he suggested naming them Tylosaurus thalassotyrannus. And then he followed it with which is also really good. But like T-Rex was better. Thalassotyrannus would have been really good. But then he followed that with parentheses grown ? And we thought it was so funny. So we included that in the paper. Our own thing was like kind of funny because like I thought of it as an undergrad when I was visiting Kansas. I got to do that during a winter break, and that's where I visited what would now be the largest specimen of Tylosaurus Rex, which is the Bunker specimen. Bunker is from Kansas, so it's one of the two that was not found in Texas, but it was found in the Pierre Shale, which is slightly younger in time than most of the Kansas Tylosaurs. Bunker, when you walk into the museum at Kansas University and look up, it's like spiraling above you. There's a cast of it, and it's 43 feet long, so it's like really intimidating. The real Bunker in collections, like, is also pretty impressive. Sorry, the dog's being annoying.
That's okay.
It's also really impressive. The skull is as long as I am tall. So that stood out to me. And just the chunks of it are all so huge. I was like, man, it'd be so funny if this thing was something else, if we get to name it T-Rex, because it's just so big and so bad. And like fast forward like 5 years. And we're working on these Texas things, and my co-author and I were like, all right, well, they're all kind of big. Let's compare them to another big mosasaur, which was Bunker, which at the time was called Tylosaurus proviger. So I was pulling up my pictures of Bunker from Kansas, and I was like, hey, I don't think this is proviger, actually. Like, it's got all of these hallmarks that we would see in our species. And that's when we double-checked the locality. So Tylosaurus proviger is typically found in the Niobrara Formation, specifically in layers that are about 84 million years old. Bunker was found in the Pierre Shale, which is only 80 million years old, so 4 million years younger, which is a lot of time for evolution to happen, for speciation to happen, especially in mosasaurs, which are hypothesized to have very quick species turnovers. So, yeah, that was it started. So that's right. That's when I told Mike, my co-author, I'm like, hey, so I had this joke to myself that if Bunker was ever anything else, it had to be Rex. And he laughed really hard. And he's like, I think we should ask Ron about that. That's really funny. We should just do it. Who cares? I'm like, okay, good point. I'm glad we did, because it's been really fun. And I think I've said it in other interviews, but like, I think if any other if any other large reptile deserves the name Rex, it's definitely this one. Like, it's huge. It's got serrated teeth. It would have certainly been like nasty and powerful.
Yeah.
I think it deserves it.
You know what I'm not looking forward to about this whole new Mosasaur thing is the Facebook comments arguing about who's biggest and who's bigger over the next like forever.
They're
Under
always they're
every
gonna do
post
that.
ever. Like, oh my
Yeah,
god. Now we just have a new player in the game, right? As
yeah.
like the least mattering question of all time. It's like who's better. But there's gonna be some more. But whatever, it is what it is, I guess. So talking about, you just mentioned kind of how, impressive and ferocious these animals would have been. Um, have you noticed any interspecies uh, injuries, combat that you think were caused by other Tylosaurus Rex on the fossils that you guys have checked out?
Yes. So there's one specimen. So a couple of them have bite marks. There's one specimen in particular that is like one of the nastiest sets of pathologies I've ever seen.
Cool.
So the Perot Museum nicknamed it the Black Knight after the Monty Python Black Knight character that just gets chopped up and keeps kicking. This thing has some of the gnarliest injuries I've ever seen. Like the jaw it has multiple bite marks in it. And some of them like seem to have interrupted the growth of one of the teeth, and like the jaw is busted and some of the face is missing. Like it's crazy. Sorry, the animal's getting on my nerves.
It's okay. You're good. You're good. Don't worry.
Deciding to like beat up everything on the floor, I guess. So the Black Knight specimen has all of these really severe injuries all in and around its face, and like it seems to have survived for some amount of time. We don't know. We're going to write it up formally. It's been presented on it at conferences. That's one of our next target projects, is to talk about that thing in detail.
Cool.
But like there's nothing else alive, and that animal's not small. Like it's not the biggest, but it's one of the bigger ones. So like I don't know what else could have made those injuries on an animal that large, because there's nothing else known at that time that would have been able to do it. So
yeah, I don't anticipate you to have like an official like scientific answer, but like in your opinion, can you give me what you think those interactions might be? Like, do you think they could be territorial, predation, or courtship, like some sort of sexual like interactions? Like, I know there's a lot of hypotheses about like tyrannosaurs and that happening, like with face biting and stuff.
Mhm.
Like, do you have any personal ideas as to what it may be, or your opinion even?
Yeah, I think because we do see facial injuries in mosasaurs broadly, and they seem to have some kind of pattern to like where exactly they are in the face is different for different kinds of mosasaurs. That's not a project that I'm working on, but it's something like I've picked up on. I think I've seen it presented. But yeah, so facial injuries are very common. Other injuries are common as well, broken tails and injuries in their limbs and stuff like that. Those, because they're like not super traumatic, I think could definitely be courtship or just general territorial social behaviors. With the Black Knight, I think whatever attacked it was trying to kill it. I don't know why. I mean, they're big lizards. Big lizards tend to not be friendly. Like even if they hang out together, they're not necessarily enjoying it in the way that like social mammals like to hang out together. Yeah, so I have no idea. Probably territorial. It could have been trying to eat it. They were cannibals. We don't have evidence of that in this species, or direct evidence, but there is another mosasaur fossil from Angola that has not one, not two, but three other mosasaurs inside of it as gut contents, and one of them is the same species. So yeah, and it's just the skulls, so it's just like ripping their heads off. I don't know what the deal is with that. If that was a behavioral thing, if it was scavenging, whatever, I don't know. But yeah, so it could have been any number of things, but the fact that the injuries on that specimen were so severe, like I think that was not just a simple like courtship kind of deal. They were very much not happy with each other, whatever it was about. I don't know, but
Yeah. You know how few minutes ago I was saying very few animals kind of earn their like headlines, words, and stuff? It's stuff like this that is what like makes me think like, okay, maybe these ones do. Like, because every time, and it's one of my favorite things about things like mosasaurs and tyrannosaurs, and you know, like me, my favorite fossil animal has always been that big owl. Like since I was a
Mhm.
kid, it's never changed. And a lot of that is because, you know, all the cool injuries and this and that. So I find things like that really interesting. And when I'm reading about mosasaurs or reading about, you know, listening to podcasts or whatever, something that constantly comes up is interspecies combat. And so I'm not surprised in the slightest that you guys have suspicions that these things were doing nothing, you know, shy
Mhm.
of beating the crap out of each other for one reason or the
Yeah.
other. But to hear it is pretty cool.
Yeah.
A little fun one. Do you have like, if you could think of like a dream fossil to find for Tylosaurus Rex, like for example, like they found ichthyosaurs in the middle of giving birth, like something
Mhm.
weird like that. Like, do you have a dream fossil where you would be like, this is insane? Like for me, it's always been like if you were to find a Tyrannosaurus Rex like on a nest that had fossilized, that would be crazy.
Yeah. I think very similar. Like a pristine skeleton with embryos would be
Yeah.
perfect. Would be incredible. Yeah.
I always thought for like mosasaurs, it would be literally just copy and paste the ichthyosaur one, where you have just half of a baby hanging out and something
Yeah.
happen. Like that would be pretty cool.
Yeah.
Or you could find like, you know how like pike and other big fish. Pike remind me of mosasaurs a huge amount, and I love pike.
Yeah.
Um, like a pike with, or sorry, a mosasaur with another mosasaur halfway down its throat that choked to death on it. Like that would be cool too.
And we get fish like that from the seaway, so it's like theoretically it could happen, which would be awesome. Yeah.
Yeah, and they're like one's like 40 feet and the other's like 20 feet. It's
Yeah.
like, oh my god. Yeah, that would be pretty cool. Is Tylosaurus Rex your favorite out of all of the mosasaurs right now?
I think so. Because like before this it was
Yeah.
Pro Rigger, and this is basically
Okay.
Pro
Okay.
Rigger. Like it's Tylosaurus broadly. Like I love them. I think they're beautiful. I think they're really cool. Um I've never been attracted to the other mosasaurs in the same way in terms of just like aesthetically how they look. Um yeah.
Okay. So does I've heard some talk in some of your interviews and whatnot that Tylosaurus Rex has serrated teeth.
Mhm.
Is that not something that the other Tylosaurs have?
Nope. Pro
Okay.
Rigger
So
sometimes. Hanosaurus does. So if we're going to proceed with Hanosaurus being valid, that is a genus of Tylosaur that was about 10-15 years ago sunk into what? Get here. Sorry. Um. So, uh, Hanosaurus was a genus of Tylosaur that was sunk into Tylosaurus about 10-15 years ago on account of it being really similar, which is fair, it is, but also because previous analyses got them on the evolutionary tree kind of interspersed among other Tylosaurs. So they didn't form a single group together. So that was a totally reasonable thing to do. But they also have serrated teeth. They also have a suite of characters unique to them. So like in our analysis, we actually do get a distinct cluster of things that used to be called Hanosaurus, which is why we're proceeding with that as potentially valid. So those guys have serrated teeth. Pro Rigger does not usually. Some of them do. It's weird. Like teeth, I don't trust teeth like at all, really, because they're, especially in lizards, they're really variable. Like they're variable individually. They're variable ontogenetically. And then something like the serrations, like they're so fine, you can't really see them with your naked eye. You have to like get a magnifying glass or actually touch them. That's something that can erode really easily in a fossil. So a character like that, like it could be variable for any number of reasons. But in Rex, like they're all there. They always have them. And the even weirder thing is like they're not common in mosasaurs generally. I've seen them in Mosasaurus and I've seen them in Prognathodon or some Prognathodon, but they're not actually technically serrations at all. So typically, when a reptile has a serrated tooth, I guess I'm not even going to think about mammals, but I imagine it's similar. But mammal teeth are really special, so I don't. It could be different. I don't know. But in theropod dinosaurs and in varanids, for example, when a tooth is serrated, it's like it has little bumps on it, like little scalloped edges, and those are like little developments of the tooth edge, um, called denticles. We don't see that in any of the mosasaurs. So it looks like you took like a crimper to the edge of the tooth. So it's like this
oh,
kind of just irregular, weird texture that like you see really clearly like under a microscope. So like in the paper we have a figure with the tooth under the scope so you can see it. And initially I didn't know about like Varanus initially, so I was like, oh, maybe this is how lizards make serrations, because the weird thing is that's how Tylosaurus does it, and that's apparently how Prognathodon and Mosasaurus do it as well. And if we back up to the different groups of mosasaurs, Prognathodon and Mosasaurus are mosasaurines. They're a completely distinct clade. So their serrations are not necessarily homologous or the same as Tylosaurus serrations. But they look the same. Okay, whatever. So maybe if this is how lizards make serrations, then there was a paper that came out in 2024 about how Komodo dragons like reinforce their teeth with iron or something like that. It's super cool. But they have these really clear pictures of Komodo dragon teeth under a scope. And you can see clear as day little denticles, just like a theropod dinosaur tooth. So mosasaurs are doing something different. I think there are a couple other lizards that do this, but like teeth are their own specialty altogether. Like they're developmentally like really complex. There's a whole different set of rules that apply to them, and you could spend like literally your whole career doing nothing but teeth, which I have not done. So like I don't know why, I don't know what's going on, but like it's really interesting to me that the different flavors of mosasaur are arriving at this morphology or anatomy of serrated teeth.
Yeah. That's really interesting. And yeah, mosasaur teeth are, I always like, whenever I look at them, I always find them, because I always think of like globidens and stuff, and then I get all weirded out. Like these things freak me out a little bit.
Yeah.
As a kid, they were my least favorite because the teeth weren't sharp.
They're cool. I want to give them some credit. Like they gross me out, but they are really cool.
I've grown up. I appreciate them these days, especially after like Prehistoric Planet and stuff. But like when I was a kid, I was like, well, its teeth aren't sharp. I don't care about it. Like I want it to have sharp teeth. I was always like, yeah, the herbivore dinosaurs are boring. The carnivore ones are cool. Then I was like, okay, but like Oranosaurus is like fucking awesome. Like one of my favorite dinosaurs. Anyway, okay, so I'll keep you. You go for about another 15, 20?
Yeah.
I know you're busy. I think maybe we'll do an hour. We usually do about 2, but I don't want to keep you that long. I know you've been doing these like nonstop.
Yeah. No. My main limitation is like it's like 80 degrees up here.
Perfect. Yeah, that's fine. Okay, let's do an hour. I think an hour and 10 max. And I'll obviously cut all this out, or I won't, because a lot of the time I don't, and I just forget and I leave it all in, and then people are like, "You're supposed to cut this," and whatever. I'll cut it on the next one. So okay. What was I going to ask? So talking about mosasaurs, do you do any other like marine reptiles, or are you like mosasaurs are your thing?
Yeah, it's mosasaurs.
I think that's
when I do other research, which like I'm manifesting because it's been in the works for years, but theoretically my next publication, other than the one that's already accepted, the next paper that I'm working on is actually back to the gecko embryo stuff. For me, it's like lizards first, and mosasaurs happened to be a lizard that I thought was really cool and that I specialized in, but like, I don't know jack shit about plesiosaurs and ichthyosaurs. Like other than they exist, like they're also like so weird because they don't have living relatives at all, and they're really freaky and derived and crazy. So I don't know a whole lot about them at all.
They are freaky and weird and gross. So lizards, what's your favorite lizard, not including mosasaur? I gotta ask.
That's a hard one. I should have an answer to that pretty easily, and I don't. I like
good contenders out there. There's some cool lizards.
There's so many. Like it fluctuates. It depends on like just what I'm thinking about. Like I probably would circle back to monitor lizards broadly just because I think they're gorgeous. They're the best. Yeah. But like geckos, like I said, I spent like my first research was actually on geckos. Like I love them. I've got a leopard gecko in there next to me.
Nice.
I love them. I think they're very cute. They're very sassy. Like geckos broadly are very sassy. I also love tegus. Like tegus in that kind of that whole flavor of lizard. I just think they're so cool. They're beefy.
You ever see that model? There was a model someone did a few years ago. They sculpted of a mosasaur, but they based it off of the structure of a tegu, and it was beautiful. It was so pretty.
I've had it bookmarked for literally years because I'm like, one day if I have $1,000 to blow,
it's beautiful. The big jowls and the color, it is so pretty.
It's genuinely like one of, if not my favorite depiction of any mosasaur.
Yeah, me too.
Ever.
It's up there.
Yeah.
Ever since I was a kid and discovered like, hey, these lizards almost certainly like had like flicking tongues like a snake or a monitor lizard. That's been one of my favorite things about mosasaurs. I think
Yeah.
that is so incredible. And the idea of them having like the big, thick tegu tongue instead of the thin monitor lizard
Oh
tongue
yeah.
is, even though I'm more of a monitor guy, that big, thick tongue on a tegu is like such a cool image in my head that's like my unofficial head canon is like, I'm going to choose to believe that they had big, fat tongues.
Well, and that's probably correct. So like we do sometimes get the hyoid bones, so the throat bones, throat and tongue bones basically. And based on the shape of those, like they're pretty short and stout and robust. So it's more likely that they did have maybe not even a tegu, it might have even been shorter, like more like a Gila monster.
Oh,
That's what I tell
cool.
people like to base it on is like it's more short, fat, thick, like not super long like a snake's or a monitor's at all. Based on the few hyoids that we do have, which I didn't describe it, but we're like 90% sure that one of the weird bones preserved with Bunker, the big ass T.rex, is a hyoid, which is pretty awesome because they're not super common. But there's nothing else that has that shape. It's like this weird, like cylinder basically. Um, but yeah,
Have you guys found any Tylosaurus Rex skin impressions yet?
not unambiguously. I mean, there's Tylosaurus skin impressions kind of floating around in the ether, and they're all pretty similar from what I've seen. I've seen skin impressions of like Prorigger and Prorigger-esque things, and then I've seen skin impressions of some of the earlier forms. So Kansasensis and the Pelicus are the other two species that lived a little bit like even earlier, so 85, 86-ish million years ago, and they're all the same. So they would have been very like snake-like diamond shaped with a little keel down the middle.
Cool. I like that. Um, so these I'm gonna assume Tylosaurus Rex is probably at the top of the food chain. When they're adults, their predators are
Mhm.
themselves or nothing. Is
Probably.
maybe the consensus most likely. Can you go maybe into not too much detail, but a little bit about with what we know about where they're found and the geologic time of where they're found? What kind of a rough like what would these things be eating?
Yeah, so they're from about 80 million years ago. So that's like peak Western Interior Seaway. So you've got all kinds of different fish and sea turtles and pterosaurs and other things interacting with the seaway. They would have really just had their pick of whatever. At this time, I believe like at this time, like some of the other clades of mosasaurs would have evolved and would have also been diversifying some of the smaller bodied things. And marine reptiles, of course. Like I say marine reptiles meaning non-mosasaurs. So the other so plesiosaurs primarily. I'm not super familiar with the ones that are found in Texas. I believe they have found plesiosaurs there of this age. I just don't know offhand which ones they are or if they're exactly the right time period. Because there's actually a lot of Texas seaway deposits, like spanning a long range of time. So it's going to be a place to watch for paleontology research in the next couple of years because more people are going out and finding more things. There's a very robust collaborative relationship between the avocational paleontologists down there and the museum. So there's a lot of working together to find these things, to get them cleaned up by volunteers, and then to have them formally accessioned and available for research, which is really nice. And that's something that's like I've been telling people is also a key part of this study is how much of it was the community and hobbyists, like people who it's not like their day job to be a paleontologist, but they still go out, find things in their backyards, and then also work with the museum.
Yeah, there's a lot of people that I follow. Um, I was talking to you earlier. Jared Cook is one of them, and he was doing a lot
Mhm.
of stuff in Texas. Maybe all of his stuff in Texas. I can't remember exactly, but
Mhm.
one of the things that I realized very quickly that like for me, like I'm a reptile guy. Paleo is like a very close second. Like they're very neck and neck. I'm very interested. I have no professional
Mhm.
experience with anything paleo, even close. But it's like there's many a day I wish I could go back and kind of go into that field more. But I've always had places like one day I'm going to volunteer to go here and try to, you know, do some digs, find something, volunteer to go out in the field. My top is always wherever I can find Allosaurus. That's my
Yeah.
number one for sure. It always will be. But Texas is getting up there because I
Yeah.
see so much stuff about Texas these days on TikTok and YouTube and Facebook of people, just scooping up around the dry mud in Texas, and here's a mosasaur and here's a shark. You know what I mean? That it seems like a really incredible place for these animals. And I mean, you found the T.rex there too, so
Yeah.
I mean that's pretty cool.
Yeah.
Is do you okay? So there was only two not found in Texas, you said,
Yeah.
and they were both where?
Kansas.
Okay, and they were both in
I want to
Kansas.
say I want to say Logan County. I'm not, don't quote me on that, but it's in the
Okay,
paper. So there's,
okay,
I mean, obviously there's many different counties and stuff like that, but in Kansas there's different like layers of rock preserved, and so the rocks that these two were found in is different from the rest in that it's Pierre shale, so it's different formation from the Niobrara, where most of the stuff that is found there is like prorigger. Um, and so it's different temporally. It's in line with the Texas stuff. So the Texas stuff is from the Ozan Formation, which is about 80 million years old. And then up in Kansas, a different formation, also 80 million years old, it's a Pierre shale. So those two are kind of anomalies, but not really, because they have all the right anatomy and they're living at the same time. And the seaway would have extended all the way up there as well. And like they're large animals, just or large marine animals. So just like large marine animals today, they would have been capable of covering large distances. They weren't. I don't believe they were super geographically restricted.
yeah. I was gonna ask that next. Like, do you think they were geographically restricted? Because in my unprofessional, naive mind, I would assume that they probably could just go wherever the hell they wanted, pretty much.
Yeah,
You
basically.
know,
Mhm.
like I know that there's do you have any weigh in or like idea of what the consensus is of whether or not mosasaurs were more towards warm or cold blooded? Because I think I've heard that there is an idea that they were maybe pushing towards warmer.
Yeah, and that's my understanding as well.
Okay.
Again, like that's those studies are based on histology, which is like cutting open the bones and checking like for growth rates and stuff like that. The last study of that was done quite a while ago, and we're kind of overdue for another one, kind of overhauling and just double checking. But that was the consensus of that paper was that they were relatively active, fast growing, fast moving, likely more warm blooded than not.
So can go wherever they damn well please, probably.
Yeah,
Yeah,
absolutely. Mhm.
which is not surprising. So, like, if you guys found, I mean, I don't know what the hell the planet was looking like back then. If you guys found Tylosaurus Rex in a similar aged rock over in, I don't know, another continent, would you be surprised, or would you kind of be like, yeah, that makes sense?
I wouldn't be too surprised. It would depend on where. So
Yeah.
Tylosaurines broadly seem to be a primarily Atlantic fauna. So if you partition the oceans into Atlantic and Pacific, you've got Tylosaurus and Hanosaurus things in the Atlantic. So North America, Europe, Africa, kind of all around there. But then in the Pacific, you actually have a very distinct flavor of Tylosaurine called Tenephosaurus. They've been found in Antarctica, New Zealand, and Japan. And they're very different. So I said earlier that Tylosaurus and Tylosaurines broadly all look the same. Tenephosaurus is the exception to that. They look very different. Like you'd be insane to try and call it Tylosaurus. Like even though I don't believe in genera, like I don't think they matter. I would not want to call that thing Tylosaurus because like anatomically they're super distinct. They're kind of weird. And they bounce all over kind of in the tree as well, which is kind of bugging me out. I feel like something's going to change with them soon. I don't know what exactly. It's one of the things where like the vibes are off and I don't know why yet. Um but yeah, so like if we found a Rex in the Pacific, I'd be very surprised because currently this flavor of Tylosaur is not known over there. If we found one in Europe or Africa, I would think it would be super cool, but maybe not super surprising. Because we do kind of get the inverse. We get in Europe, it's primarily, or it's all Hanosaurus, or what has been called Hanosaurus. But then you get things in North America that are also Hanosaurus adjacent. Like they're more Hanosaurus adjacent than Tylosaurus. And so, like, these things were clearly capable of crossing those distances. The problem we're running into is like we don't have an exact snapshot of every period of time on Earth in every spot. The fossil record is fragmentary. You don't have rocks of the right age in all these places. So it's hard to get a complete picture and to like know for sure. Um, but yeah.
Okay. All right. So not surprised by the answer, but it's very cool to hear because the idea of animals in general, like birds freak me out the way they do this, but traversing global like not territories, but just like
Mhm.
population and whatever. It has always been really interesting to me. Um, yeah, that's really cool to think about. And I will be putting photos and whatnot of the species you're bringing up in the episode, especially the one you said from what was the weirdo you said that?
Tanephosaurus, and I'm gonna write it in the chat because its name is
Yeah,
not
please
spelled.
do.
It's not spelled the way you would expect. I recently learned that that was the right way to pronounce it. Um,
What is this? That's not what you
yes.
said.
So it's I can't. It's named after a deity in a culture, and I can't remember which culture, but it's like a native language name for it after like a sea beast kind of a deal. So it's pretty cool. But
Oh,
I learned only like 3 months ago that the WH is pho and not wa.
okay. So I looked it up here because I couldn't wait. I was really excited to look at this thing. I was gonna do it right when we were done recording, but whatever. It looks it looks like its head is like its skull is very narrow, like narrow and long. It looks like.
It's narrow. I mean, and that's a Tylosaur thing. What's weird about it is the way that it kind of bends, like it has like a kink in it. Um, and then also like again, like
Okay, I see that.
it's got like a weird turn to it up front, and then just the shape of the quadrate is wrong or different for this group. The quadrate's the ear bone, basically. Um, and then something else that's really strange is the shape of its skull roof bones. So it's frontal and it's parietal. Um, just look, they just look wrong. Like for a Tylosaur, they look very different. They don't come together in the same way. They don't articulate the same way. So in Tylosaurus, there's like a series of flanges that kind of overlap and interlock there. I don't believe that's the case for this thing. It's just really strange, and I don't. I mean, there could be any number of reasons for that. In general, the Pacific record of mosasaurs is nowhere near as complete as the Atlantic. So, because in the Atlantic we get bits and pieces of that fauna from the seaway because these things are going in and out of the seaway, and we get more bits and pieces from Europe, which is also like mostly flooded at this time. So, like, we have a relatively good picture of what's going on in the Atlantic, not so much the Pacific. And like everything that comes out of there is very weird and very different looking. I think
Hmm.
like the Plioplatycarpines look the same because they're weirdos everywhere anyway. But the mosasaurines get very strange. They actually have the mosasaurines have a copycat tylosaur shape. It's called Plesiotylosaurus, which has like a rostrum, which is the Tylosaurus character. But it seems to be a mosasaurine that independently evolved that. You get Plotosaurus, which is like a mosasaur trying to be an ichthyosaur. Like it's really strange. It has this really long, skinny face with a weird kink in it. Really, really solid skull relative to the other species. Um, a lot of weirdos in that Pacific fauna, and I don't know. What that suggests to me is that those two fauna diverge pretty early, which is interesting. And then that they don't like intermix after that. I don't know. I hope more stuff is found over there though to help kind of fill in those gaps and complete the picture because the oceans were still connected back then, so they would have been interacting and evolving together somehow. But how, I have no idea at this time.
Yeah. That's really interesting. I like the idea of them being super. Well, I mean, of course they were super diverse, but like just every time I talk to you or another, somebody who studies mosasaurs, that gets hammered more and more that these animals were incredibly diverse. And every time I hear names I've never heard, and then I get to look at pictures of weird looking mosasaurs for a few hours while I edit, which is awesome. Because
Yeah.
last time I did a mosasaur episode, it was like it's probably my most edited episode because I was like right into finding photos and stuff. And I don't know, maybe I had a lot of time on my hands at that time too, or
Yeah.
something. But yeah, it's really cool, and I can't wait to see because, like you said, it's kind of like there's not that many, right? But like so like there's more out there. So like
Relatively, yeah. So, like, I mean, the number of species to number of specimens to number of time passed in that range of specimens doesn't add up. So, like, until this paper from the United States, I'll say from the United States for this entire chunk of time. So, like, 90-ish million years ago to about 75-ish million years ago, there were two species of Tylosaurus,
hmm.
which is kind of stupid. It doesn't make a lot of sense, and it turns out that's not actually what's going on. So, like, we allude to another project that I have in the works, but like I've presented on it, I've cited it, the abstract is public, so I don't mind sharing it. But there was a third species, well, now fourth, of Tylosaurus called Tylosaurus cansacensis that was sunk into Nepelicus. These are the earlier living ones in 2016. And so, in our reassessment of Tylosaur diversity and anatomy and ontogeny and all of that, we've decided, like, okay, actually, this thing deserves to be recognized as distinct. So we proceed with that with this paper, just because we wanted our results to actually be accurate as possible. It would not have been accurate for us to knowingly exclude something that we're recognizing as different, especially when it's an existing species. Like, it's not really big news to have a species in there that was already published. It was named in 2005. And like, it's not Nanotyrannus. It's not going to make the news big, like when we resurrect that thing fully. But it's a similar kind of situation where a lot of variation was overlooked as ontogenetic variation when actually, when you compare these animals to their living relatives and have a broader sample size, you start to see that, okay, actually this variation is tied to other things. So it's tied to locality, it's tied to stratigraphy, it's tied to other things, and it's consistent and it's not changing ontogenetically, or it's like directly, at some cases, directly at odds with how we see ontogenetic changes occur in modern lizards.
Okay. Awesome. So to close us out here, I'm going to ask you the same thing I ask any paleo people that will ever come on here, because I think everybody in the world should be asked this question at least once like a month. Your favorite actual dinosaur?
Carnotaurus.
Oh, that's a good one.
Easy.
Carnotaurus.
I've always loved it.
I assume as well. For me, I love Carnotaurus, but I'm always frustrated by the samples, like, or lack thereof. I'm pretty sure there's like one skeleton or something like that.
There's one. And like, it's a good one, but
yeah, it's really awesome, but I want more.
Yeah.
Like, and this is, I mean, coming from somebody whose favorite is Allosaurus, I'm a little spoiled. There's no shortage of my favorite, right? So like, yeah, Carnotaurus is awesome. Is there does that stem from something, or has it just always been? Like, for me, Allosaurus, it's because of the Walking with Dinosaurs series since I was a kid. Like, it's been Allosaurus because of that.
It's probably because of the Disney dinosaur movie.
It's like
I don't know
one of my favorite movies as a kid.
Yeah, but it's like that would have been my first time seeing it anywhere, so probably that.
I was hoping that's what you'd say, because that movie rocks.
Yeah, no, it's awesome. Every now and then I go back to it. I'm like, all right, yeah, this kicks ass.
I showed my fiance that movie like 3 months ago. I was like, "You've never seen this? Like, hold on, now we're gonna go watch it." And the whole time, she's like, "Yeah, I guess it was okay." You know, this looks a little weird at times because it was shot in such a weird way. I think it was one of Pixar's first movies, or their first like animated in that way or something like that. So it kind of looks weird at points. I don't care.
Yeah,
I don't care at all.
It holds up pretty well.
Oh yeah, I thought it looked great. Like, the intro to that movie is unforgettable. Like, the score and everything. Anyway, thank you so much for coming on, Amelia, especially on such short notice. I really appreciate it. Brennick apologizes he can't be here. We don't care. We didn't miss that sucker. Is there anything you'd like to promote or say before we sign off here? Anywhere to find you?
Yeah, so folks can find me on social media pretty broadly. I'm on most of them. I think Threads is the only one I'm not really active on at all. And also, if you want to learn more about paleontology in general, I also have a YouTube channel called Skeleton Crew Paleontology. It is myself and 4 other paleontologists. So that was kind of the premise, is we wanted to be paleontologists who actually shared research, like how it works, our perspective. And we do that mostly through video games and other media. So using that kind of as a gateway to talk about specific things. And instead of doing the traditional, well, actually, and correcting them, we lean into what they get right specifically and focus on that.
Awesome. That's awesome. That's a really cool resource. I'm going to check that out myself. And then all that stuff will be in the description. And so you can check out all of Amelia and friends stuff there. Thanks again. Congrats on everything. Super awesome. And anytime I get to nerd out with anybody about this kind of thing is a good day for me. So I really appreciate it. And yeah, thanks guys for watching, and we'll catch you in the next one. And recording here. Thank you for tuning in to Creature Crossing. Please check the description for social media links, Patreon, and more. Feel free to subscribe and leave us a review. The song used for our intro and our outro is called The Snake Eater's Palace, Outer Heaven by Audio Mocha, Anime Vivi, and Endless Repeat, which we found at ocremix.org. Thanks again for listening.